Okay, what's up? So let's look at some graphs. I'm not even sure what we're going to do here. Remember the general form of a linear equation. Do you remember? Y equals mx plus b, right? This is, by the way, I'm on Desmos. I highly recommend you check it out. I probably told you. Now this thing's pretty cool. It can recognize that m and b are like these fancy variables. You can add a slider so you can control the value a bit. So for example, if I've got b as 1 and m as 1, so remember m is the gradient and b is the y-intercept. So you can see here it goes through 1, right? That's the number 1, that's the y-intercept. Why is it zooming so slowly? And it goes across 1, from here, across 1, up 1, across 1, up 1. So the gradient is 1 divided by 1, which is just 1. You could even go across 3 and up 3. But again, 3 divided by 3 is just 1. Alright, but anyway, I want to try. Actually, let's do that. As we change the gradient, it gets steeper. So if the gradient's 3, it goes across 1 and up 3. Across 1, up 3 to 7. Okay? Notice the y-intercept is still 1. It can get even more steep. If it's 10, it's going to go across 1 and up 10. So it's going very steep. If you go to 0, it goes completely flat, meaning it's not changing. The gradient is sort of like the rate of change. So if it's not changing, it just stays at whatever it started at, which in this case is 1. If it's a fraction, like a half, it should go across 2 and up 1. The gradient's 1 over 2, a half. Rise over run. If you do, can I do 0.67? I'm going to try to do 0.7. Are you kidding me? There we go. It should be about 2 over 3. See how it nearly goes through this? That would be 2 over 3, 2/3, which is 0.67 or 0.66666. So it's a little bit more than that. And if you wanted to approximate, in fact, if we go across far enough, see it goes right through there. So see here it says 10 and it says 8. So it went across, but it started at 1. So it went across 10 and up 7. So 7 over 10. Anyway, look, let's do something different. Don't worry if that didn't make sense. We're going to do, let's say, 3x plus 5. So it goes through 5, and the gradient is 3. So if I go across to 1, where's 1? Here, it goes up to 8. So from 5 to 8, it goes up 3, and it goes across 1. So 3 over 1 is just 3. And the y-intercept is 5. Let's say this time I want something that goes through 4 and goes down to 4 here. Okay? Now I know what that is, but let's see. The y-intercept has to be 4, so we know that part. Now what's the gradient of this line? Well, it goes across 4 and it goes down 4. So 4 divided by 4 is just 1. But the only thing is it's going down. So it's going to be minus 1. So see if you can work out what that is. You could think of it as minus 1x plus 4. But you don't need the minus 1. Just minus x plus 4. And you can even do 4 minus x. That's also fine. So see, it goes through 4 and 4 is going down. Okay, what else can we do? Let's try a fraction. Actually, let's try something like 3x plus 2 all over 4. Okay, so let's think about that. Why has it got brackets? Get rid of them now. Okay, the gradient of that is actually just 3 over 4. So that's the gradient. So it should go across 4 and up 3. It's a bit tricky. It goes through here and here. Okay, so see that's right on the grid. So 1, 2, we should go by the numbers. This is the number 2 and this is the number 10. So it goes across 8 and it goes up from 2 up to 8. So that's 6. So 6 over 8 is the gradient. But if you simplify 6 over 8, it's the same as 3 over 4. Actually, you can use this point as well. That's 5. So the height here is from 2 to 5, which is 3. So that height is 3, and this is 4. So 3 over 4 is 3/4. The gradient should, the y-intercept is just 2 over 4, which you can simplify to a half, 1 over 2. So that should be 0.5. See? Okay. Alright. I might leave it there for now.